Hello students, welcome to plus 2 class. Today we are going to study solution chapter. First of all, we will discuss the definition of solutions. What is a solution? A homogeneous mixture of two or more non-reacting chemical substances is known as a solution. A solution always have single phase. Based on the number of chemical substances mixed to make a solution, the solutions may be known as binary solution, ternary solution, quaternary solution, etc. First of all, we will discuss the simplest types of solutions, and there are binary solution. What is a binary solution? As the name of binary solution is itself suggesting, the word bi means two. So it is clear that a binary solution must have two chemical substances. So a solution composed of two components only is called binary solution. The examples of binary solutions are, for example, sugar solution and salt solution. In a binary sugar solution, the sugar is solute and water is solvent. Similarly, in a salt solution made up of two components, there will be common salt, NaCl, solute in that solution, and water will be solvent. Similarly, a ternary solution. Ter or tri are numerical prefixes for 3. So a ternary solution is composed of 3 chemical substances called components. For example, a solution of both sugar and salt in water. In such a solution, there are 3 components: sugar, salt and water. That is why the solution is termed ternary solution. And similarly, the prefix quarter means 4. So a quaternary solution is composed of 4 components. For example, if we add glucose to this ternary solution, the total components will become 4 and it will then be called a quaternary solution, and so on. Now we will discuss the terms for components of solutions. In a simple binary solution, there are two components. One is solvent and the other is solute. First, what is a solvent? The component of a solution which is present in largest quantity is called solvent. If two substances are mixed, then the substance which is present in greater proportion is solvent. If more than two substances are mixed to make a solution, then the one which is present in excess over all the other substances will be a solvent in general. Solute. The component of a solution present in lesser quantity is called solute. Suppose a solution contains more than two components, then the one present in the largest quantity in general is solvent, and all the other components present in lesser quantity will be solutes. One important thing to remember is physical state, that is sometimes called phase, of solvent and solution is always same. For example, in a syrup. What is syrup? A thick or highly viscous sugar solution is called syrup, and the physical state of syrup is liquid. So a syrup is liquid solution, generally containing 60% sugar, and the physical state of sugar is solid, and 40% water. In this case, even though the amount or quantity of water is lesser than sugar, but still the water is solvent because the phase of the water and the phase of the syrup are same. So the water having the same phase as that of solution is solvent. Now, based on the relative amount of solute in different solutions, the solutions are of four types: dilute solutions, concentrated solutions, saturated solutions, and supersaturated solutions. Dilute solution. a solution containing relatively small amount of solute in a large amount of solvent is called dilute solution. For example, a 2 normal H2SO4 solution. In a 2 normal H2SO4 solution, there will be 2 gram equivalents of sulfuric acid present in 1 liter of net solution, and it is considered as a dilute sulfuric acid solution. Concentrated solution. A solution containing relatively large amount of solute is called concentrated solution. For example, 36 normal sulfuric acid solution. If we compare these two solutions, the quantity of solute sulfuric acid is low in this case, so it is a dilute solution, and the quantity of sulfuric acid is relatively higher in this solution, so it is a concentrated solution. The next term is saturated solution. What if we take a fixed amount of liquid and keep on adding a particular solute in it? We observe that after a certain limit there will be no more dissolution, and such a solution formed is called a saturated solution. So the proper definition of a saturated solution is a solution in which no more solute can be dissolved at a particular temperature is called saturated solution. And finally, super saturated solution. A solution containing more amount of solute than that required for saturation at a particular temperature is called super saturated solution. Remember this, the supersaturated solutions are unstable. If they are left in standing position without disturbance, they undergo precipitation or crystallization and become heterogeneous. That is why the supersaturated solutions are unstable systems. Now we will discuss types of solutions based on the physical state of the solute and the solvent. Based on different physical states of solute and solvent used to make a solution, the solutions are broadly classified into three categories. Number 1, solid solutions. Number 2, liquid solutions. And number 3, gaseous solutions. And in total, there will be 9 classes of solutions. So we will discuss all these 9 categories with examples one by one. Solute, solvent, examples. First of all, gas in gas type of solution. Second will be liquid in gas type of solution. Third is solid in gas type of solution. Fourth is gas in liquid type of solution. Fifth is liquid in liquid type of solution. Sixth is solid in liquid type of solution. Seventh is gas in solid types of solution. Eighth is liquid in solid type of solution. And finally the ninth is solid in solid type of solution. As we have discussed earlier, the phase of the solution is always same as the phase of solvent. That is why the first 3 solutions in which the solvent is gas are gaseous solutions. The next 3 in which the phase of the solvent is liquid are liquid solutions. And the last 3 in which the phase of the solid solvent is solid are solid solutions. Now, some examples of these various type of solutions. Example of gas in gas type of solution is mixture of oxygen and nitrogen gases. Because the solute 21% in air, the O2 is gas, and the gas which is present in larger amount in atmosphere, that is nearly 78%, that is nitrogen, is solvent. So both the solute and solvent are gases in a mixture of oxygen and nitrogen. So air, or you can say a mixture of O2 and N2 gases, is a gas in gas type of solution. The next is liquid in gas type of solution. Example is chloroform in nitrogen gas or mist. Chloroform basically is liquid, but when its vapors are dispersed in nitrogen gas, it will form a solution belonging to this category. The example of solid in gas type of solution is camphor in nitrogen gas, or the vapors of any other sublimable solid in a gas. One more example is smoke, in which the tiny unburnt solid particles of fuels are mixed in a gas or air. The example of gas in liquid type of solution is CO2 dissolved in carbonated beverages like soda water, beer, champagne, etc. Or simply that oxygen dissolved in water. The example of liquid in liquid type of solution is alcohol in water. Both the alcohol and water are liquids. And one more example is benzene in toluene. Here also both benzene and toluene are liquids. The example of solid in liquid type of solutions is sugar solution, in which sugar is solid and water is liquid, and similarly salt solution. The example of gas in solid type of solution is hydrogen gas occluded over palladium metal. The palladium metal has a strong affinity for hydrogen gas, and that is why it is also used as a hydrogen storage media. And hydrogen gas adsorbed, and the adsorption of gases on solid metals is called occlusion. So we can say hydrogen gas occluded over palladium is an example of this category. The example of liquid in solid type of solution is metal amalgams. The amalgams are mixtures of mercury liquid metal with the other metals, in which the amount of liquid mercury metal is lesser. For example, zinc amalgam or sodium amalgam, etc. And the example of solid in solid type of solutions are alloys. For example, copper in gold. Now we will discuss the properties of a solution. Properties of a solution. Number one, a solution consists of one phase only. So, a solution consists of a single phase. Before mixing the components of solution, the phases of the various components may be different, but the final phase of the solution must be single. Next property is the size of solute particles in a true solution lies in a range of 10 raised power negative 7 to 10 raised power negative 8 centimeter, or you can say 1 nanometer to 0.1 nanometer. Next property is the composition of a solution is not within certain limits. For example, a sugar solution may have very small amount of sugar in it, or relatively more amount, or relatively further more amount, or it may be a saturated sugar solution also. So the range of the solute, that is sugar in case of sugar solution, can be varied from very dilute concentration to saturated solution. The next property is the properties of a solution are the properties of its components. That is, the components do not lose their properties when they are mixed to make a solution. The next property is the components of a solution cannot be easily separated by physical methods like filtration, sedimentation, centrifugation, etc.